Function f is a quadratic function. The graph of y equals to f of x in the xy plane has a vertex at -7, 14 and passes through the point negative 4, -31 and has a y-intercept at 0, a. The graph of 3 times f of x has a y-intercept at 0, b. What is the positive difference between a and b? Since f is a quadratic function and it has a vertex -7, 14, we can write the quadratic function f of x in vertex form. That is, f of x equals to p times x negative h the whole square positive k. Usually when we write a quadratic function in vertex form, we'll be using a lowercase a over here. But here I'm using p because already we have the lowercase a as a y-coordinate at the y-intercept. To avoid confusion, instead of lowercase a, I'm using lowercase p over here. And h comma k represents a vertex. We have the vertex -7, 14. So h comma k equals to -7, 14. Okay, now let's plug in this -7 for h over here and 14 for k over here. Then we get f of x equals to p times x and negative of -7 the whole square positive. The value of k is 14. Then we get f of x equals to p times x negative times negative is positive. That is x positive 7 the whole square positive 14. Okay, still we have to get the unknown constant p over here. For that, we can use a point -4, -31 because the question says the graph of the quadratic function f passes through this point. So let's plug in this x coordinate -4 for x over here and this -31 for f of x over here. Because we know that y equals to f of x, this f of x represents the y. Okay, then we get -31 equals to p times for x, we have to plug in -4, positive 7 the whole square, positive 14. Okay, now we can subtract 14 from both sides of this equation. Then this positive and negative value will cancel out. When we combine these two values, we get -45 equals to p times, when we combine -4 and positive 3, we get positive 3. That is p times 3 square. Okay, let me continue over here. -45 equals to, and the value of 3 square is 9. 9 times p is, we get 9p on the right side. Okay, now let me divide both sides of the equation by 9 to solve for p. Okay, here this 9 will cancel out. When I divide -45 by 9, I am getting -5. On the right side, we have p. Okay, here I got the value of p. Now the quadratic function we have over here is complete. That is f of x equals to -5 times. That is, I plug in this -5 for p over here. X positive 7 the whole square, positive 14. Okay, now let's find the y-intercept of the quadratic function f of x. Okay, whenever I want to find the y-intercept of any function, I have to plug in x equals to 0. Then we get f of 0 equals to -5 times 0 positive 7 the whole square, positive 14. Okay, f of 0 equals to -5 times 0 positive 7 is just 7. That is 7 square, positive 14. Okay, let me continue over here. F of 0 equals to the value of 7 square is 49. Then we get -5 times 49, positive 14. Okay, f of 0 equals to -5 times 49 is -245, positive 14. Okay, f of 0 equals to -231. Actually, this f of 0 gives the value of y when x equals to 0. That is, this gives the y-coordinate of the y-intercept. Already we know that x equals to 0 and the y-coordinate of the y-intercept is -231. Okay, here I have written the y-intercept as a point. But already we have the y-intercept of the quadratic function f of x. It's over here. That is 0, a. Okay, this 0, a and this 0, -231. Both of them represent the same stuff. That is y-intercept of the quadratic function f of x. Okay, now let's compare this one and this one. At the place of a, we have -231. So therefore, the value of a is -231. Okay, here I got the value of a, that is -231. Still, I have to get the value of b so that I'll be able to get the positive difference between a and b. Okay, now let me write the given quadratic function, that is y equals to f of x. For the given quadratic function, we got the y-intercept, that is 0, -231. Now, to get the value of b, we have to consider the information we have over here. That is a graph of the function 3 times f of x as a y-intercept at 0, b. Okay, now let me write this function over here. That is y equals to 3 times f of x. So for this function, the y-intercept is 0, b. Once we get the y-coordinate of the y-intercept of this function, so then we'll have the value b. Then we can get the positive difference between a and b. Now let's compare the quadratic function y equals to f of x and the other function y equals to 3 times f of x. Here we have f of x, the same function we have over here, but 3 is multiplied. So that is a vertical stretch by a factor of 3. Now, to get the graph of this function, we have to multiply the y-coordinate at each point of this quadratic function by 3, because there is a vertical stretch by a factor of 3. The same thing we have to do for a y-intercept as well. That is, to get the y-intercept for this function, let's consider the y-intercept of the quadratic function y equals to f of x. We have to multiply the y-coordinate over here by 3. When I do so, I am getting negative 693. Okay, here I got the y-intercept of the function 3 times f of x, that is 0, negative 693. But the question says that the y-intercept of this function is 0, b, but here we got 0, negative 693. At the place of b, we have negative 693. So therefore, the value of b is a negative 693. Okay, now I have both the values a and b. Now we can get the positive difference between a and b. Okay, so whenever I want to get a difference between two numbers, what I have to do is I have to do subtraction between them. That is a negative b. Since we have to get positive difference, let's take absolute value for this one. Even if a negative b is negative, because of the absolute sign we have over here, it will be positive. Okay, already we have the value of a, that is a negative 231. Let me plug in. Okay, let's take this negative sign. And the value of b is a negative 693. Okay, here absolute value for negative 231. Negative times negative is a positive 693. Okay, here when I combine negative 231 and positive 693, I am getting 462. Absolute value of 462 is 462. Therefore, the positive difference between a and b is 462.